Area of a circle. Here we go. Area of a circle. Already went over it. Here we go. 18. Area of a circle. Pi r squared. There we go. R for radius, everyone. R for radius. Pi r squared. Everyone, right now, for sector, I'd like, instead of just reading the definition and trying to explain to you, I want you to try to draw your own picture. Take a circle right now. Go ahead. Draw a circle. Draw in 2 radii in that circle, please, going to anywhere. 2 radii going to anywhere. Okay, what you have formed right now by drawing the 2 radii and the arc around it. The 2 radii and the arc around it. I don't think I can do this probably, but I'll try. Nope, didn't think so. That is called your, try that. That is called a sector, bounded by 2 radii and an arc. Right there, that is called a sector of the circle. Think of it as a piece of pizza, piece of cake, a pie, wherever, all right? That is called a sector, bounded by 2 radii and the arc. More formulas, here you go. How do I find the area of that? How do I find the area of any sector? Well, you guys already know from last unit, it was a little rough, but it was there. I could name this angle in degrees or radians. There's 2 different formulas. First formula. Does anybody remember the arc formula? The length of an arc formula, just off the top of your head. Anybody remember that one? Length of an arc, Saad? Okay, stop right there, because that's the first part of this area of a sector. Measure of arc. Yeah, good. Measure of arc over 360. And then what'd you multiply it by for the length of the arc? You remember? Circumference. I don't want to multiply it by the circumference if I'm going inside the circle. Any ideas what I want to multiply it by now? The area, pi r squared. Pi r, yes. And whatever note you have to make, the measure of the arc has to be in degrees for you guys to use that formula. Okay, the measure of the arc has to be in degrees. What if it's in radians? Well, you can convert it to degrees if you want, if it's in radians, or use this following formula if it's already in radians. 1/2 r squared theta. And a reminder, theta is the central angle in radians. So take a look at those 2 right now. One is for radians only, one is for degrees. If you rather just use one and only one, like you prefer to use this one, fine. Just make sure you're always in degrees. Make sure you're always in degrees if you want to use this one. Any questions on finding the area of a sector before we get after it? All right, let's go. Read through. Measure of arc E of BC is 108. Some students wrote the formula to find the area of the sector, COB. Just so you guys know what they did, again, area of sector COB is this area right in here. That's what they're finding the area of. That sector right there. Okay? So 4 kids did it. 2 of them were right, 2 of them were wrong. So which ones found the correct formulas? Well, let's do this formula out on our own right now. Am I given degrees or radians right now? 24, degrees or radians? The arc measures in degrees. So I'm going to use that arc, 108, over 360, the formula I had just given you in degrees, times what? Here you go, 5 times what? The measure over 360 times, okay, pi, what's my radius according to this problem? There is none, okay? All right, so I'm just going to put pi r squared. They actually plug in the segments in a second. All right, let me go through each one with you. Amy, right or wrong? And if she's wrong, tell me why. Look at Amy's. She's saying 3/10 times pi times BC squared. Is she right or wrong? Tell me why she's wrong if you think she is. 28, let's roll. Why? BC is not a radius, it's a chord. It is not chord squared, right? Everyone see that. BC is not a radius. Amy, see you later. Get some self-respect. What about Big Beth here? 23, right or wrong for Beth? Why are you going to say wrong? Beth is using? She is right. What's OC? Radius. So pi r squared, 108 over 360. Nice job, Beth. Carl, the C-man. 11, right or wrong for Carl? Ooh, right. Even though he has a 3/10 in there. I don't know if that's throwing anybody off, but anybody know what 108 over 360 reduces down to? 3/10. Yeah, hey, that reduces down to 3/10 here, guys. And he's taken, where's, who had this one? What's AB, Amanda? And when you take half of it, you get the? Nice job, Carl. And finally, Dex. I'm sure it's short for Dexter, huh? Big D here. 2. He is wrong. I see 108. I see the pi, and I see him taking 1/2. Is he taking, which one do you have to do first here, James? What's he squaring? Oh, hold on. What's he squaring here? AB, which is what in the circle? Yeah, he should be squaring the radius, right, everyone? Not the diameter. So, Dex, you're out. Beth and Carl, congratulations. You can stay in the class. We are right there. See if you can do number 2 on your own. Basic sector problem now. Central angle 60. What's the area of the sector? If you need to draw it out, go right ahead. Radius of 6 inches. Looks like you're going to leave your answer in terms of pi. Okay, but we have a relationship from the circle unit, how the central angle relates to the measure of the arc. That was the one we learned. That's the theorem we learned, yep. All right, let's roll here. 22, where are we at? 22? 22? Okay, I'm not asking you to be done. I'm just asking a quick question here before I move on to somebody else. Measure of the arc. They gave me the central angle. Last unit, what's the relationship between the central angle and the measure of the arc? They're congruent, so that's got to be 60 degrees. That's why I'm using this formula, because the arc is in degrees, not radians. So 60 over 360 times pi, 6 squared. 8, calm down. How about 8? There we go. 60 over 360 times 64 pi. Again, pi's got to be in your answer according to the multiple choices. So all I'm going to do is 60 over 360 times 64, turn it back to a fraction. Anybody turn it back into a fraction? 24, turn it back into a fraction. What's the issue? 60 over 360 times 64. Okay, 32 over 3 pi. Hey, are we okay there before I move on? Okay. Yep. Okay, that's not a big deal because you get a decimal in there, right?
Well, yeah, but where's the, what type of calculator should I bring for the regions? Because I don't want to have to waste some time trying to figure out all this stuff.
Well, it shouldn't. For like something like this, you could just go through each multiple choice and find out what's equivalent to that decimal you got here. So it really doesn't matter what calculator you end up having because there's always a way around not having the graphing one. We all good? All right, read over the next one right now. Read over the next one. So you have the area now. You have the area of the sector, and you're trying to find the measure of angle AOC. $10. Where's 10? Oh, of course not. I should remember that. 27. Okay, here we go. What's the 12 pi, Justin? So I know that's going to be equal to, give me a formula here I can use. Area of a sector. What formula here? Yep, look back if you need to here. And we'll stay in degrees because it doesn't be specific, so we'll stay in degrees. What? Okay, stop. I don't know the measure of the arc, so I'm just going to call it x, everyone. All right? Over. Yep. In this case, r. Okay. Now, everyone, do you realize when you find x, you'll be finding the measure of AC? But why will that also be my final answer as well? Even though they didn't ask for the measure of arc AC, why is x going to be my final answer? 27 again. Because they're asking for angle AOC. So once because you're finding this right now, the measure of the arc. Why is the measure of the arc? There we go. Everyone good? All right, help me solve it now. I'll do this part. 12 pi equals x over 360 times 36 pi. Little trick for you kids. 20. What do you have on both sides there? Pi's. See you later. Eventually, they're going to cancel each other out, so you can do it now if you want. 12 equals x over 360 times 36. And see how your algebra skills are there, moving things around. And eventually, what do we end up with here? 22? Okay, I got a question for you. Because we use this formula, is this 120 degrees or 120 radians? Degrees, correct. So that's 120 degrees there. Questions from you guys? All right, I'm going to do one more with you, and then you have example 5 with the rhombus on your own. All right, here we go. Love these problems. Love them. A figure on top of another figure. Find the area of the entire patio. Find the area of the entire patio. What's on top? 2. What's on top there? Trapezoid, so area of a trapezoid. And what's on the bottom? 20. What's on the bottom? Semicircle, so plus the area of a half circle. Yeah, buddy. Here we go. Let me get the formulas out. Not needed to show me, but just want to do this. 26, Area formula for a trapezoid.
1/2 height times base 1
Got it. Plus area of a circle. Here you go, 20, area of a circle. Pi r squared, but everyone, I'm going to take and put a half with it. Everyone all right, because it's half a circle. Hey, everything's here for you guys. Everything is here. Help me fill in the trapezoid one right now. Trapezoid, 25 trapezoid. Half the, what's my height? Bases. Got it. All right, let's go to the circle. Here you go. No one? I'll do the circle, sure. 1/2 pi. Diameter up there looks to be 10, so I'm going to go 5 squared. All right, so I end up with, let's see, 34 over here, right? Plus 12.25 pi. Hey, everyone stop right now. Can everyone just stop and look up here? Stop, look up here, please. I know you're rounding to the nearest tenth of the foot, but let's say I change the directions to leave your answer in terms of pi. Everyone see what I have up there, 34 plus 12.25 pi. That's in terms of pi. Okay? You cannot combine these two and just put pi with it. All right, Andrew? Is it 12.5? Okay, 12.5.
When you're doing that out on your calculator, 1/2 pi 5 squared.
Yep.
What order do you multiply?
It doesn't matter. It's multiplication. Order doesn't matter when you multiply or add. So everyone, all right, that's in terms of pi. All right, if I ever ask you, aka the next problem you're going to do on your own, when it says leave your answer in terms of pi, that's as far as you can go. All right, now go ahead, round it to the nearest tenth. And we end up with, to the nearest tenth. Go ahead, 23, nearest tenth. 73 point, I didn't hear the rest. Square feet. Everyone okay with that? For what? Yeah, I know, because I left it as 12.5 pi. I bet you if you do...
I got 39.3 and you said you got 70.
No, I know, but you got to add that to 34 now.
Oh, okay.
Right? Because that's the area of the circle. Now I add the area of the trapezoid. Questions? Okay, in your group right now, let me see example 5 with the rhombus and the 3 half circles now. You're going to have to use some properties here. Leave your answer in terms of pi. See what you can do in your group. Discuss it with each other. The rhombus should be pretty easy for you. You just got to work for how to find that diameter on one of the circles. All right, I'm not going to reveal how I got that though. All right, you're going to have to work a little bit. How to find the diameter or the one side in a rhombus. Use your properties. Use your properties of a rhombus. Should be doing some Pythagorean theorem to find the side of the rhombus. Diagonals bisect each other. They're perpendicular. And you have 1.5 circles. If you're getting it, go ahead. Go on to the next one. Go ahead. Go on to the next one. Finding the shaded region. If you got this in terms of pi. If not, if you're still struggling, let me know. I'll come over. Anybody, any places we're having issues with the rhombus one? But diagonals bisect each other, so 5 and 5, 12 and 12. Pythagorean theorem will get you a side of the rhombus, which equals the diameter of the circle. Just make sure when you're doing the circle formula, you multiply by 1.5 because there's 1.5 circles up there. Okay, questions? Okay, I'm moving on. Find the area of the shaded region. Everyone see the shaded region? Okay, the shaded region, I have no idea how I'm going to find the shaded region because those aren't sectors. Because remember, sectors are with radii. How could anybody have a plan to find the shaded region? Because you're going to finish this one for homework in a second. Go ahead, Rose. Okay, so hold on. Area of the half circle. Yep, I'm hearing you. Go ahead. And do what with those two to find the area of the shaded region? Subtract them out. Yep. So you guys have 1/2 pi r squared minus 1/2 base times height. And you know it's a right triangle because they gave you it. Never mind. I was going to pull a circle fact out, but they already gave you it's a right triangle. So keep grinding on that, and I will ask you how you finished it tomorrow in class. Keep going. What about it? What do you mean? I take this half circle. The CB is shaded. It doesn't look like that, but yeah, CB is shaded. Yeah, it's part of the whole shaded region. Okay? Yep.